See, the video that I'm presenting is very slow. You know why? Because I'm using a laptop, okay, with a low speed and minimum memory allocation. So in this case, we are using high performance computing. We can discretize, okay, high performance computing into distributed parallel computer system, or shared memory architecture, or hybrid architecture, which is integrated between the distributed and shared memory. And towards the end, there is an extension version, okay, where to get accurate result, okay, to get high resolution, to have a good monitoring and observation, we need some specification. For example, we are doing a discretization, dimension, okay, increase the dimension in terms of space and time, the behavior of the initial condition, the data extraction, and some mathematical modeling towards numerical simulation and the numerical analysis, okay, for get the performance of the method that we are going to choose. All right. So to do that, okay, there are two types of simulation. One is a data simulation. The second is a model simulation. So to do, okay, the process of data simulation, okay, we propose the conceptual framework in V-cycle. The first is, okay, how we convert the actual process, okay, to the mathematical modeling. For example, in this room, okay, we want to reduce the temperature behavior in this room. So how we model it? To do it, okay, we need a model we call partial differential equation with the parabolic type, depends on space, the dimension of this room, and then the temperature behavior, right? The time independent. By doing this, okay, we need to scale, okay, the model to the numerical simulation and then run in the parallel form, okay, with the good parallel programming. In this case, we are using some communication protocol, for example, CUDA, PVM, MPI, method distributed computing, and then other communication protocol, and implement on high performance computing and get the result in terms of the validity, verification, analysis, parallel performance evaluation, and numerical analysis before we get a good prediction, a good visualization, and good high resolution. Okay, for example, I'd like to share with you, okay, some fundamental theory and complex mathematical modeling, how the temperature behavior in your handphone, right? There is no wire in your handphone, all are naked wire, we call as a nano wire, generated by CVD, all right? There is no, you can see a silicon wire, okay, all in the device. So to get a temperature behavior for the multi-layered full chip system in your handphone, okay, we can model in the parabolic equation, in the Poisson equation of the elliptic equation with some parameter involved there, and we can visual multi-dimensional environment for the temperature behavior and some parameter, other parameter, for example, density, pressure, and so on. To do this, we need big data simulation on high-performance computing system. All right. Okay, we have so many CPUs in our home, right? Okay, we want to see that when the temperature increase, the power, okay, will also increase. How to adjust the temperature behavior and the power generated when we are using CPU, all right? Especially when we want to use distributed parallel computer system, where we manage to combine a number of CPU working together as a distributed parallel computer system to minimize the cost, to develop a large space memory allocation, and to high speed of the computational cost. Right? So when we put a sensor, okay, at the location, okay, we can design the temperature behavior related to the voltage that we need to support the CPU running in the distributed computing architecture. All right? So to do that, we also need big data simulation, high performance computing platform, and some knowledge on parallel algorithm. Okay, people this one of the example that I'm doing research, okay, how to deliver a drug through a blood flow to the specific cell. Alright? When people have a breast cancer or brain tumor, alright, they can go for chemotherapy, radiotherapy, and others. However, if the tumor in the brain, it is not easy to remove or not easy to do some treatment. So the new technology is a nanotechnology to bring a drug, okay, to a targeted cell. Right? To bring a drug to the target